Hello, welcome to all present here. I'm Andrei Valik, CTO and co-founder of 3DV company. And today, so I can say, but I hope you will understand me well. In any case, you can ask me some questions in chat, and I will answer later. A few words about our company. Our company founded in 2011, and there are more than 30 engineers, developers, and we developing software in computer vision and deep learning. So our key products are face recognition SDK and API, full body skeletal tracking SDK, and object detection. Our key customers, Intel, such companies, Intel, LG, Rubik, Orange, and more. So today I will tell about our face recognition software. We provide two main products for face recognition. The first product is Face SDK. This product for developers. It's a set of libraries for video and photo processing. It's native libraries for different operating systems and different platforms for development face recognition solution for any scale, from simple mobile application or desktop application to a portal to a cloud like Azure Face API or Amazon recognition. So if you developer Face SDK is a product for you. The second product is Face Machine. This product for integrators and developers, of course, can use it too. It's turnkey components with integration API for real-time face recognition from video stream and from images consisting of face machine server. We provide face machine server in our cloud, or you can use it on-prem, and face machine client application used for real-time face recognition from video stream on edge devices. So the main difference of these two products is the first product, Face SDK. For developers, it's libraries without storage, just processing, just to build your application, your solution from scratch. And Face Machine, it's for integrators. It's ready engine with storage like a Face Machine server and with Face Machine client application that can be worked on edge devices. So at the first, I will tell about a Face SDK. It's a more simple product than Face Machine. Face SDK has the next functionalities. The first, it's face detection and tracking. So you need detect face from images. And the next functionality is face identification or verification. Also, we provide two-dimensional, three-dimensional liveness checking for access control system, for time attendance systems to avoid some spoofing. And we provide face analytics functionality like gender, age, and emotion estimation. it can be used for digital signage solutions. And we provide our Face SDK for different platforms, Linux, Windows, Android, and for different operating system, and for different platforms like Intel platform, Intel desktop or server, ARM platform for embedded on mobile system. And now we are testing and preparing release for iOS operating system, and I hope it will be released this month. Also, we provide a few languages. It's C++. It's a native language for Face SDK. So C++ interface is native and fastest interface for Face SDK. Java language, it's Java wrapper of C++. You can use it on any operating system. And C# language supported also. We hope that next year we will support JavaScript language for web-based application, but it will be in the future. Next, we processing images or video streams begins from face detector. So you have to detect face in frame, in image or set of frames. This functionality provided by face detector object or capture, how we call it. It detects faces and return a raw sample object, one raw sample object for one face. So in some images, you can detector can find a few faces and return a list of raw sample objects. Raw sample object contains face position or in original image, like a bounding box, face angles in 3 dimensions, roll, pitch, yaw, and landmarks, and face ID. It's from special detector from tracker that used for detect face in set of frames from video stream. And raw sample provide such functionality like face cropping according to standard for biometric documents. So after face detecting, you can crop face and store to some your storage or to some your document according to biometric standards like ANSI or ISO. And next, this is timing for detector. You can see that detector takes time a few hundred milliseconds for detect faces in full HD image or simple HD image. And we provide a few different types of detectors for different cases. For example, we provide detector with wide enhanced angles of faces, but it will take more time for detecting. And we provide a special video tracker detector for real-time processing set of frames from video stream. So you can see that time of detecting for video tracker, it's modern CPU will be around 30 milliseconds. It will be around 30 frames per second for detecting for people in Full HD video stream. And we provide different detectors for different use case. For example, when you fill your database, you can use a special detector for single face. When you pass detector image to detector, you know that minimum one face inside this image present, and this detector will find more object more similar to face always and return this face. This detector can be used to avoid skipping some images with noise faces, for example, to process as more images without errors as possible during filling of database. And next special detector is for video streams. I already talked about it. It's for real-time processing set of frames. It's optimized for real-time processing, optimized for CPU usage, and make real-time processing video stream. So you can choose detectors that you need for your task. And after detector, we have a raw sample and can pass it to encoder. Encoder receives raw sample object and construct a template object. Template object contains vector that can be used for comparison, for face identification or verification, and encoder name or version. This operation takes a lot of resources, and for example, the most quality encoder takes around 1/2 of a second for encoding one face. And template object provide a method to store or load templates for database storage or network transmission. It's for easy to store templates on your storage, for example. And we provide different encoders for different use cases. For example, for expert system, we provide encoder with maximum quality. You can use it for make identification in a huge database with hundreds of million faces. But when you have time, for example, you have a time to encode one face in 1/2 of a second, and this encoder and this algorithm or method of identification used for expert system and used for searching one unknown face in a huge database, in big database. And for video processing, we provide next version of encoder. It's in 6 times faster than previous one. So you can use it for video processing in real time and encode each frame from video stream on desktop or server platform. And the third encoder, it's for mobile application. It's in 5 times faster than previous one. So you can use it in mobile platform for video processing in real time or photo processing. It's the fastest encoder. Each encoder different from each other by quality, not so more, but a difference in speed for different use case. We update our algorithms once per year at least to maintain top position in NIST competition. And new method released a new version of Face SDK, but each version of Face SDK contains all previous methods too. So you can upgrade Face SDK and use it in your software without pre-processing all your database immediately, because you can use all previous methods in a new release, new releases. And next functionality of Face SDK, it's a matcher. Matcher, it's object that compared to templates, to vectors. It has 3 different modes, verification modes, one-to-one comparison mode. So you just pass 2 templates to matcher, and it return a score of similarity. And the second mode, it's identification mode. This mode is used for identification for big database, for big shortlist or some shortlist. And this mode is accelerated and optimized for speed. If verification mode speed around a few hundreds comparison per second on one CPU core, identification mode speed is 40 millions comparison per second in one CPU core. It's very fast, and you can use it for identification with 10 or 100 million database. And group identification mode, when you pass a group of templates and make identification across a big database. This mode used for occupied all resources and for search, research your database, entire database when you make, when you're at stage of filling your database, fill your database. In this mode, we test, for example, we tested this mode on 16 CPU, with 16 CPU cores, and we receive speed 800 million comparison per second with such CPU. So it's very fast, and you can search against 1 million faces, for example. And workflow is simple. You just, for identification, you construct templates gallery or templates index from one point, and pass to matcher templates index and query template, and receive list of matches. It's identification list, and you can ask matcher return only first 10 closest templates from database or 20. So you can change size of list of matches. And processing workflow. So at the first, you have to enroll your faces in a database. So you can see at the bottom of image, you pass photos, images with faces to detector, next to encoder, next store it to database, construct template index, and pass this template index to matcher for matching. And the upper of image, you can see real-time processing thread. So you just take one frame by frame from video stream, pass to detector tracker, and receive raw sample, pass to encoder, and next to matcher, and receive matches. So this base processing workflow. And next, depth length. We provide such object for access control system, for time attendance system, to avoid some spoofing, to be sure that you identify a real face, not fake. And this depth LivenessEstimator receives two streams. One stream is or one frame from depth sensor. You should use special 3D camera, and raw sample from usual RGB stream or usual RGB image, and it will return real or fake face, just answer. We recommended to use the system when you need fast depth estimator, the fast LivenessEstimator, because liveness could be two-dimensional or three-dimensional. Two-dimensional uses usual camera, usual RGB camera, but can be spoofed by some big image, by some big picture or video, but when you use 3D camera, you can control a shape of face, and it's more real. It's like the same technology in iPhone X. Yeah. And this workflow with depth liveness, after detector, you send a raw sample object to depth LivenessEstimator and receive answer real or fake, and depends of this answer you can pass data to encoder or not. And other parts similar with the base workflow. So as you can see, it's no complex solution, but you have to combine a few objects for real-time processing. And if you have a few video streams, you should construct a few one combine of such objects for every video stream, for each video stream. And in this case, for example, you will have to use for one matcher for one video stream. it's no optimize because matcher is very fast, and you can use one matcher for for 2 or 3 or 5 or 10 video streams, because it can match, it can compare with speed 40 millions in one CPU core. And you can optimize your cost and optimize your resources of your solution. To help you in this optimization, we design a special object, special component like VideoEngine or video worker. It's used for real-time face identification from video stream only. And this component combines inside detector, encoders, and matchers, and some special logic for face identification and face processing that optimize it for real-time processing and optimize it to decrease CPU usage. For example, if you detect some face in one frame and encode it and search in your database and found it, you don't need to detect, you don't need to process and search it again on the next frame. So you can optimize your resources if you will realize such logic. Or if you see that face in next frame that you don't identify before, but try already search cross database. In next frame, you receive this face with worse quality. You don't need process it again. You don't need to encode it again. You don't need spend resources to encode it because it quality less than previous, and you won't identify it in any case. So such special logic allow to us optimize usage of resources, CPU usage during real-time processing of video stream. And such logic realized inside this component, VideoEngine. You just send one frame by a frame to VideoEngine from one side, and pass template index from database to VideoEngine, and receive events of face detection, face loss, and face identification, or true identification or false identification, for example. And you can send a depth map from 3D sensor to VideoEngine, and in this case, it will make depth liveness checking for you, and will receive here event about real and fake faces. Event received by callbacks and a lot of different events for the use case. And this is how to construct a VideoEngine inside. It can process a few video streams. It's unlimited number of video streams, depends of your resources, depends of number of cores that you have on this computer, on this CPU. And for each video stream, used one face detector and tracker, and there are a set of encoders that share it with all streams, and set of matchers that share with all streams too. For example, in one video stream, what is the advantage of this usage? In some of video stream, this time could be, for example, 10 faces. and in another video streams, no faces. In this case, all encoders will be used to process these all faces in this video stream, and you you will receive all maximum results. You will receive all that all results of all faces, for identification all faces. So you can share your resources, depends of face flow in different streams. And we recommend to use this ready object, this ready component for video stream processing. It's easy and fast. And next component, it's age gender estimator. Just receive a rough sample and estimate age and gender, and return your object with age and gender of face. It can be used in face analytic, in digital signage, and some other analytics. Next, emotion estimator, and the same. It can be used for face analytics too. We provide 4 emotions: natural, happy, angry, surprise. We recommend to use emotion, not absolute emotion. We recommend to use to analyze how emotion changes, because it's more real information than absolutely emotions. You know, when you see on some people, you cannot understand it's happy or maybe angry or maybe surprised, yeah. But when emotion changes, you can understand it. So we recommend to use changing of motions in your solutions. And next, I think about Face SDK. It's all. The main thing that you should understand, it's a product for developers, for develop your solution from scratch, for develop small application, for develop big application, you choose. And next, our product is a face machine. It's 10K components with API for real-time face recognition in video stream in images. It includes face machine server. We provide it on our cloud, so you can ask, and we will send you some trial access to this cloud, so you can test it. It's a storage of face images, templates with that can be combined in some groups, that can be sent to edge devices for real-time identification. A lot of different functionality. And next component is face machine client application. This component runs on edge devices, so you just download installation and install it on your device. After installation, this component connect to server, download a short list for identification from server that according to this device, and receive video stream from your camera and make identification from video stream. This component can provide your identification events by RESTful API or by calling your application your scripts and send identification and detection events to face machine server for store. This solution, face machine, designed with Face SDK components. So you can design, you can develop your solution if you have time or you have another vision for this solution. What we recommend to use it to optimize your time, and this already solution with API for usage. We use Docker containers technology for fast and easy deploy and upgrade these components. And we use Kubernetes cluster framework for high availability and high scalability. Face machine REST API for fast and easy integration, and face machine available as 3DV Face Cloud, or you can ask us, we will provide you a set of containers for on-prem installation. And you can use it completely offline without internet and so on. And this is how work face machine components. Face machine server use PostgreSQL database engine, and it contains processing engine for encode input images when you enroll faces in database, matching engine when you input a new face inside database, it search against database, and you have a search list for each face. Face machine server use GraphQL API for database manipulation. So you can build your own interface, your own user interface, or you can take our interface as example at start point and customize it, rebuild, or make white label, use it at start point for development user interface. And we provide web interface as example, dashboard, edge device management, create shortlist, combine image faces to shortlist and send to device, receive and store events from edge devices. Edge devices run face machine client on edge devices. So it works on edge devices based on VideoEngine SDK component. So it receives shortlist from face machine server, performs face identification one-to-many from video streams, and send events to face machine server, and send events to your application by REST API, and can call special external scripts on some events. So you don't need to use REST API, and you can just write some scripts and configure face machine client, make some task in your scripts. It's easy. And we provide some bundles, hardware bundles with face machine client, face recognition terminal. You can see on our site this solution. So you can use this ready terminal for example for access control system or time attendance system, or we provide user interface part in sources, so you can use it for develop your user interface for customization, anyhow you want. Okay, and it can work with 3D cameras, or it can work with two-dimensional cameras for depth liveness. It can work without internet connection to server sometime. For example, it can receive short lists from server and after work offline, and produce identification event without connection to server. It's sometimes it's very important. And face machine client available for desktop platform and for mobile platform, so you can use it on some mobile or embedded devices. About real-time video processing. So the main points, it's use special optimized face detector tracking to meet frames per second target. Our tracker can use 15 FPS instead of 30 FPS from cameras for resource optimization. You can process video streams on edge device and send events to server, or receive real-time events locally. Fast time with low latency, without latency at all. And use special optimized encoder to process all detected faces. To process all detected faces on embedded devices or desktop platform. You can use several encoders per one channel in case of multiple faces in 1 frame per second. For example, in public places, in big entrances, you can use it with VideoEngine Face SDK or Face Machine Client. It's ready components for this case. I use shared pool of encoders for resource optimization, and use one matcher for several video streams for cost optimization. So these main points of real-time video processing, its challenges we recommend. And some comparison, some cloud processing and edge processing. What we have with cloud advantages, it's easy for configuration and deployment, of course, easy for support and personal security. It's easy, usual for us when all personal data placed in one server, for example, and you can protect it. But we have big limitations with cloud processing. For example, if you need to process a lot of video streams, you have to use a big internet channel for video streams. And it's impossible to receive real-time events because of network latency present, and it's impossible to work without internet connection, of course. And edge processing, it's of course main advantages. It's low latency, could be offline, Personal data protection can be implemented by send only templates to each devices without any personal data, and it could be fast and easy deployed and upgraded by using Docker containers technology too. So we recommend to use edge processing for real-time video face identification. A few words about Liveness check. We have there are some mistakes in the slide. There are two Liveness check ways. The first, it's a one-frame Liveness check that used in access control system or time attendance system when you need a fast Liveness check, when you have a big flow of people in entrance and have to make Liveness check every frame fast and easy. So in this case, we recommend to use 3D Liveness. We have experience in such solutions when for face identification for Liveness takes less than 1 second, and it's a big flow of people in entrance, and hard to fake, and recommend for high-end access control system. And two-dimensional Liveness check, it's of course not so expensive, but easy to fake. And another type of Liveness, it's Liveness with scenario. For example, you can ask people move or rotate head and check head angles, and if our detector, will detect that it's a real head with shape, not a flat head. But this Liveness takes more time. It's 5 or more seconds. It's used usually for verification in some personal applications, some mobile application could be used. And for corporate solution, of course, face identification, usually it's a complex solution with a big database, with multiple video streams, and with client-server architecture, and some requirements like high availability, high scalability. So development of such solution takes 3 months at least in our practice, and 6 months usually. And we recommend to use our development pack. It's a special pack of our offer. In this pack, we provide a personal support engineer via chat and email. We provide architecture support. We will help you construct architecture of your solution for cost and for resource optimization. We will help you develop fast your solution. We will provide you for your unlimited number of licenses for development and testing. And you will receive renewal of development licenses during this development pack time. And you can you will have 100% rebate for conventional licenses. So for this, for cost of development pack, you can take commercial licenses when you move to production stage. So it's not for development only, it's for production stage too. And we strongly recommend use our development pack. And about our licenses, we can provide you custom license for with any set of components of Face SDK or Face machine components, any set, any numbers. It depends of your requirements. You can take all-in-one SDK license from our site for fast start or for fast testing. We can provide mobile application development license. You just with just one flat fee and unlimited installation. So you with this with such license you can develop your your own application, and you can install your application on unlimited user devices. But limitation of this license is that it's binded to application ID. But it's easy, it's very often used for public mobile application. And enterprise license, one flat fee, no royalty. You can use it with unlimited development and unlimited installation. So it's like a big enterprise license with no limits. YTV, yeah. Video processing is our strength, and you can develop your solution fast and quickly. You can access to low-level libraries like Face SDK, or you can use our ready solution like Face Machine. You can use edge computing offline, and you can use Face Machine on-prem without internet connections. And just connect to us, and we can offer for you what you want. And I think that enough. Our time go to end. And, okay, questions. Let me see. Do you have some examples of real video face detection without file database, what is faces from MySQL? Or, examples, do you mean sources, examples with sources? Yeah. Yeah. With our Face SDK, we provide demo software with sources. One of demo that called video recognition demo. This demo load faces from files from file system, connect to web camera, and make identification from video stream. You can download our Face SDK, and you receive inside this SDK this demo with sources, and you can use our Face support by email if you will have some questions about this examples or about Face SDK. So. And you can check documentation of Face SDK. We provide tutorials for face identification with pictures, with sources, with some commands. So just download and check. Can the measure the B change with time, like if university first? My measure the B may change every month. Do you mean change database inside measure? It's easy. Can the measure the DB change with time, like I have used for university face attendance? My measure DB may change every month. I think you mean that your database changes every month and you need to update measure DB. Yes, of course, you can just update if you need update maximum size of matching index, you can update license. It's not a problem. Updating database inside MatchDB is possible by interface of MatchDB. Yes. So my answer is yes. While doing a video face recognition on premise, can we change the MatchDB every hour? Yes, of course. Not a problem. MatchDB receive only, let's say, not a real object. Receive only reference to templates. So you can change your list of templates, template index on fly, and change very quickly, very fast in one time inside MatchDB. So it's not a problem. So I think I answered all questions in chat. In any case, you can ask and connect to our ask by email to face.tv.com, and you can download Face SDK and you can request to use Face Cloud. We plan to release a new Face Cloud with web interface in a few days, and we will send email to all our customers about this news. I hope it will help. It will be in this week. Okay. And I think that's all today. Thank you. Thank you for connect that you listen to me. Bye.